The second. Hey guys, welcome back to another XF Motorsports video. In today's video, we're going to show you the automated manual and pneumatic shifter that we configured for the ASL 55 in preparation for our final CSCS Time Attack event this September. So just showing off the old system before we show you what we've added to it, but this was the original pneumatics designed by Sherrar when he built the car about 2 years ago, and it was actually controlled by this motor driver, which he designed for a university project and retrofitted into the car where it's at, just kind of right up in the glove compartment. But this originally controlled the pneumatics, and it was removed due to a number of misshifts, and just for the safety of the engine, he took it out and ended up just adding in this bar in to manually shift the engine for a number of events, which you've probably seen. So we're going to design a brand new circuit for this, get some PCBs printed, and develop another control system for this to prevent any sort of misshifts and really increase the speed and reliability of the pneumatic system. All right, so this is the new board that we designed. There's a number of reasons in the way that we have designed it to try and make it as quick as possible while also still having full embedded control within the system. So the main thing that you'll notice up front is we used a STM32 black pill, which is just one of their F411 boards. And the reason we did this is because of the chip shortage. It's very, very difficult to actually order these, and the chips themselves cost almost as much as these actual development boards. So although we may have wanted something more powerful like an F407 or something with CAN built into it for future purposes, this was quick, and we were able to just build essentially a shield to allow it to connect in and out of the car. But even with this, we were still able to reduce this form factor just a little bit and make it fit into the car a little bit easier. Aside from the black pill, we just have a little bit of power protection circuitry to try and reduce the noise in and out of the car and isolate the electronics a little bit, which should hopefully increase the reliability of this system, as well as the ULN chips. So these are just relay drivers. So we can see here with the pneumatics, they're just driven by relays which actuate the air valves. All this does is it'll take any inputs from the paddle shifters and use a voltage divider and an RC filter to bring that signal into the black pill as noise-free as possible, and then we'll use these relay drivers to drive the solenoid valves, and hopefully this system altogether should be much more reliable than what was existing in the car. So this is the development studio that we use to program the boards. It's just the STM Cube IDE, which is given out for free by STM for use with their chips. But the reason we went with it is it's really nice to have a visual indication of how everything's programmed. So it's as simple as you just select what pins around the board or around the chip that you have configured to different parts on the board. You can name them, set them as different inputs and outputs. So it's a really easy way to get into full embedded design while still having all the things that you want control of through the system core, timers, multimedia, USB. Yeah, so the actual board was just designed in KiCad. Again, I'm not going to go through this. Maybe we'll make another video if you guys want more on how we develop this hardware and what we're going to change for the next few ones. But one of the biggest things is I'd like to have CAN implemented on these boards, so we could just install multiple of these boards that we have in the car and communicate across them for different features. So for example, if you have like the rear wing, a shifter module, and maybe some inputs from accelerometers can all communicate to each other, hopefully save to something like a data logger, and this should improve the data capabilities and what we can get out of this ASL car. Once the board was all wired up to everything and the first version of the software was ready to test, we were able to test it with the car running just by jacking the back wheels up off the ground, and that showed a number of bugs that even with all the input filtering and power filtering that we've implemented, it was still very, very noisy signals to deal with, and we were able to mitigate that just through some extra software protection, but it just shows how noisy this environment within the car actually is. All right, so here's a demo of the final system. From our initial timings, just with the phone slow-mo cameras, we're averaging shifts between 0.2 to 0.3 of a second, everything in, including actuating the clutch, shifting, and releasing the clutch. So to turn on the system, we'll first just go here and apply power. And it'll do its checks to make sure that the system's in neutral and just re-actuate the clutch. To get into first gear, as a safety, we need to manually actuate the clutch just with the foot. That makes sure if the car's running in idle, we don't accidentally shift into gear when we're not ready. So right now, I'll just manually push down the clutch. And we've shifted into first gear. So from here, it's as simple as just paddle shifting it. We can go into second, third, and then from here, the downshifts are a bit slower because we're manually rev matching it on the track. So just to give a little bit more time, we've added a bit of a delay. And we're back in first, and then finally we can go back into neutral. Once the system was working, we were actually able to take it right out to the track to test it. And this is actually the Northern Speed track day that you might have seen in a previous video. And if you notice the shifter right here, we can watch it actually moving quite well with the paddles, but we were sure that we were able to get much faster shift times, which that's the next big piece that we'll be working on.
So that was everything for the shifter. After the shifter was complete, and well, after the CSCS, we decided to do one more track day just to take the car out on track again, improve the shifts a little bit, and also improve the ECU. The tune was a little messed up the last time we went out at the CSCS, which is why the engine wasn't making full power. And this time going out on track, we actually tried putting the engine on 15 psi of boost, which was, well, previously the engine was only running 9 psi of boost, so it was quite a lot higher. It was the most power we've ever ran on this car, so that was pretty cool. Handling wise, the car was at a really good point now. Through the corners, the car was just flying through the corners. We also made a minor balance adjustment, taking away some oversteer that the car had at the CSCS, and yeah, that worked out really well. We weren't able to put any complete laps together because this was an open lapping day and there was other traffic on the track, but comparing sector times, the car was quite a bit quicker than what it was at the CSCS, so that was really good to see. There were also quite a lot of radicals on track, radical SR3s and also one older one, so it was pretty cool. I also talked to a few of the radical people and also took one of the guys along for a test drive in my car.
So this is a Radical SR3 RSX. This is our third generation of car. So they come from around mid-2000s, and now our newest generation is the fourth gen XX. This car uses a 1340cc Hayabusa motor and uses a special diff called the GDU, the gear driven unit. Usually these cars are chain driven. So instead of that, we have a coupler at the rear, and then it goes to a set of longitudinal gears into a diff.
Cool, so this one is no longer like the older ones where you used to have like a chain driving a sprocket and...
Exactly, yeah. So this uses a GDU instead.
And like, what's the weight of the car? And
So the weight for these cars, dry, is usually around 1,300 pounds. For a racing series, it should be close to around 1,565 is the minimum weight that you can have in the car.
Okay, with
driver
the
and
driver,
fuel,
okay.
yeah, all that. So, yeah, if you think Mossport, top speed is around 200k, and then coming through, if you know turn 8, you don't lift. It's
you
flat.
just go flat out.
Yeah.
Wow.
So these cars have a lot of downforce. I think they produce around maybe 300 kilograms of downforce at top speed.
And do you find like when you take it to different tracks, like let's say TMP, or when you take it to Mossport, do you have to play around with the suspension settings, anti-roll bars, or?
Yeah, we do. We have to adjust camber, toe sometimes, depending. We really only set the cars up based on what the tire manufacturers do. We'll change it a little bit, but the tire manufacturers will give you a setup that you can use in order for the car to handle well. Mind you, Calibogie per se has the same amount of left-hand and right-hand corners almost, so we'll set the camber up almost, identical. Versus, Mossport will have a little more camber on the left side because there's more load on the left side.
What's the weight distribution of the car?
A little more rear bias, and it's actually funny, if you get the cars in right-hand drive,
Yeah.
they're actually better for corner balancing because the GDU is placed off to the left.
Do you find a lot of people that like buy these cars and modify them? Like people modify Suzuki Hayabusas?
Yeah, there are a couple people who like to modify them. Mind you, that comes with reliability problems. So these cars come in different versions of this motor. This is a 1340cc. You can get a 1500cc built by Radical itself. Mind you, the service hour on a 100-hour engine is the service on the 1340 is 100 hours. Service on a 1500 is 40 hours. Yeah.
Oh, one last question actually. So for the shifter, are you? It's a sequential shifter, of course,
Yes.
taken from a motorcycle. Is it cable driven or is it like a?
So you can hear that right now. You hear that noise?
Yes.
That's actually an air compressor. Kind of like what your car
Okay.
is, right?
Yeah.
So it has a little small compressor with a tank,
Uh-huh.
and then what it does is it has a shift solenoid, but unlike yours where it goes left, right, up and down, it only has to go back and forth because it's a barrel,
Sequential, exactly,
right?
yeah.
So that makes it very, very simple. Now, this car over here actually uses an electronic system called a Pro Shift versus this car uses an air shifter. We find the air shifter is a lot more easy to deal with. It already pre-programmed as to what needs to happen. You know, it's been in the car for so long now that they have a lot of data on it. And
For the rest of the day, we were just having fun with the car, giving people ride-alongs and getting their feedback on the car. And well, most people at first, they're scared to get in the car just because of the half-finished looks and all the carbon fiber and stuff. They think it's going to be like a kit car or something, but they get pretty blown away by how stable the car is and how well it actually handles and everything. And the car is getting at a pretty good point in terms of handling and how it feels to drive. It's actually a pretty easy car to drive, even being like it's reaching close to 700 wheel horsepower and only in a 950 horsepower car, but it doesn't feel that way. The lap time tells you that you're in a really quick car, but driving wise, it's, I would say, even easier to drive than your regular AMGs just because there's so much grip and so much downforce now. It's almost impossible to make a mistake. It's a really stable car. So next up for next year, the main challenge is going to be also, well, improving the looks of the car and finishing up on the bodywork, and also developing the aero even further than what it is right now. So I think that's going to be really cool. Hopefully also making the car look on the outside like as good as it feels on the inside. And yeah, hopefully after that, I think it's going to be a pretty good car once it's all complete. So that was everything for the E55 ASL. Things are looking pretty good with that car, and well, can't wait for next summer to get that car out again. For now, I had to park it at my place because the shop was getting pretty full. I didn't really have any space to even bring the car back here, but there's not too much work left on the car. Just need to finish up on the body work, give it a few final finishing touches, and that's going to be it for the car. Next summer should hopefully be pretty fun. There's going to be more driving than actually just building the car, so I can't even wait for that. Hopefully we're gonna have some pretty good lap times. It's already giving pretty good lap times, but I think we can even get it even faster than what it is right now, so it's gonna be pretty cool. But before we get to next summer, of course, there's quite a lot of work to get out of the shop this winter. So yeah, quickly walking you guys through all the cars that are over here right now. This one is a CLK 550, which we need to take the engine out of, and we're putting an M113 engine in it with two massive turbos and a CD09 manual transmission. So pretty much the same drivetrain that the E55 ASL has is going in this car, and well, we're going to be testing this engine out and building it the same way that we're building the F1 engine, which is also an engine that you guys are hopefully going to see running on the dyno pretty soon. But before we get to that, we do need to make a little bit of space in the shop. That's why we need to get done with this car first. This one is a Bentley Continental GTC. This was a car that we removed an engine from earlier on. It was in a bit of a front collision. After that, it was at the body shop for the longest time, getting fixed up, and now it's finally back over here. And yeah, basically we need to put all this stuff back in the car and try to get it running. But before that, we do need to also finish up on this car. This one is an SL63 that we were also, well, twin turbocharging, but before we could even twin turbocharge it, we had to work our way through some of the M156 issues. This engine had a broken head bolt. It had the older style of head bolts that these engines came with, and one of the head bolts, yeah, turned out to be broken. That's why the whole head had to come off just to remove that one bolt. And yeah, we were at the point of yeah, just putting everything back together with all new head bolts. Hopefully getting this car first running again, and then putting massive turbos on it. And yeah, that's going to be something that is going to be coming up for you guys. You're going to see all the videos on this one pretty soon. Over here we have a few other M156 engines also that are not working. This one has cylinder walls that are pretty worn out. I bought sleeves for this one, but by the time we even got to machining or sleeving this one, the person already found another M156 engine, and this one had a broken head. We replaced the head on it, and we were just putting the intake manifold and all the other stuff back on it. But by then the person, he might change his mind. He's not too fond of M156s anymore, just because of all the problems that they have. He bought these engines for a project that he had to put them in, but now I think he wants to go with the newer 4-liter engines, not the M156. So if anyone wants to buy these engines, let me know. I do need to make some space in the shop because it's getting really full. We need to make some space before we can do more work over here, because well, even this engine over here, the V12 engine that needed to go in this car, it's also waiting for the engine dyno. It just needs to be put on an engine dyno, tested out. Also, two other engines that I know of someone who is selling. They're Nelson Racing V8 engines, pretty powerful. I believe they're 2,000 something horsepower. I'll link all the statistics on the screen because I don't remember them fully, but they're pretty cool engines. He bought them for a supercar project. He was building a supercar that he wanted to put those in, but what ended up happening was that later on he changed his mind and he went with electric motors. He made that whole car electric rather than making it fuel powered, so that's why he ended up with those two engines he's trying to sell. Amazing for drag racing or even a high horsepower street application, because I believe they are built for street use. So if anyone wants those, I will link his description I will link his information in this description below as well. Oh, and also massive thanks for the 100k subscribers. Well, I didn't even check that in my channel recently, but someone actually told me that the channel had hit 100k, which was pretty amazing, because I actually never expected to reach that high with my lazy editing skills and uploading a video once a month or something. But that's amazing. Big thanks for that. Really appreciate the continued support from you guys, and hopefully, yeah, I will keep trying to improve the channel from here, bringing you guys more of this content once we do get to doing a bit more work in the shop and finishing some of these projects. But yeah, really appreciate the support. Thanks for watching, and well, yeah, this is gonna be everything for now. A little more of a delay before we get some more work done on these projects, but through the winter for sure there's going to be a lot of content coming up for you guys. So yeah, if you want to stay tuned, subscribe to the channel, hit the notification bell, and I will see you in the next one.